A baseball diamond is in the shape of a square, 27.4 meters on each side. Mary starts running home from third base at a rate of 5.2 meters per second. At the same time, Steve runs from home plate to first base at a rate of 4.2 meters per second. How fast is the distance between them changing 3 seconds after they leave? Answer to the nearest hundredth. So we're going to start by sketching this scenario. And the baseball diamond tells us it's a square. So it's just going to illustrate that with a square like this. And then we have home base down here let's say in this corner here. We're going to call that H. This is going to be first base, second base, third base. And we also know that it is 27.4 meters. And then it tells us that Mary starts running home from third base. So that means that Mary starts right here and she starts running this way. So this is Mary. And she runs at a rate of 5.2 meters per second. At the same time, Steve runs from home plate to first base. So Steve starts right here at home base, and then he runs towards first base like this. So this is Steve. And he runs at 4.2 meters per second. Okay. And then we want to determine how fast is the distance between them changing 3 seconds after they leave. So let's imagine that after 3 seconds, Mary has reached this point right here. And Steve has reached this point right here. So the distance between them after 3 seconds will be this distance right here. We're going to call that distance Z. Now, in those 3 seconds, Steve has run X meters. So we're going to label this side X. And Mary has run, she has run Y meters. So we're going to label this here Y. So from her starting position down to where she is after 3 seconds here, that's going to be labeled as distance Y. And that will mean that after 3 seconds, the remaining distance that Mary has to home base is going to be 27.4 meters, because that's the length of that whole side. So 27.4 meters minus Y, the distance she has run. So at this point, we end up with the right triangle here, like this. We're looking to determine the rate at which Z is decreasing or changing actually. We don't actually know if it's decreasing just yet. Let's identify the rates that we have. So we have the rate at which Mary is running. That's going to be dy dt. And that rate is 5.2 meters per second. And we also know that Steve is running at the rate dx dt, which equals to 4.2 meters per second. And what we're trying to determine here is the rate, how the distance between them is changing, the rate of change in the distance between them. So dz dt when the time equals 3 seconds. So what we're going to do here is we're going to express this triangle using Pythagorean theorem. The Pythagorean theorem, we're going to express the relation between the three sides in this triangle using the Pythagorean theorem. So that's going to be x squared plus 27.4 minus y squared equals to z squared. And then we're going to differentiate this. We will need to use implicit differentiation here. So we're going to get the derivative of x squared with respect to time plus the derivative of 27.4 minus y squared with respect to time equals to the derivative of z squared with respect to time. Okay, like that. So we can now go ahead and differentiate the following expression. We're going to apply the chain rule for each of the terms. So for the derivative of x squared with respect to time, the outside derivative is going to be 2x, and the inside derivative will be dx dt. For the second term here, we're going to again use the chain rule. The outside derivative is going to be 2 times the inside derivative, which stays intact for now, times the derivative of the inside function, which is so the derivative of 27.4 minus y, which is simply going to be negative dy dt. And then the derivative of the right hand side, again, chain rule. Like that. So now we've differentiated the expression. What we're going to be looking to determine is dz dt. We know the rate at which Steve is running, dx dt. We know the rate at which Mary is running, dy dt. What we do not know is x, so how far has Steve run, y, how far has Mary run, and z, what is the distance between the two of them at 3 seconds. So we can determine that because we do know how fast they're running, and we know for how long they're running. So before we do that, however, we may also notice that each term, this one, and this one, each term is multiplied by 2, which means that we can tidy it up a little bit by dividing the left and the right hand side by 2. This is not necessary, just makes it a little bit neater and shorter. So we're going to divide everything by 2, and we're going to get x times dx dt plus 27.4 minus y times negative dy dt equals to z times dz dt. So here what we did, we divided both sides by 2 just to simplify it a little bit. So now we are going to go ahead and we're going to determine x, y, and z, those specific distances. So we're going to determine x, y, and z. Okay. So x is going to be equal to the speed at which Steve is running, which is 4.2 meters per second, and he's running for 3 seconds. Which means that in 3 seconds he has covered 12.6 meters. For Mary, she's running at 5.2 meters per second. And also running for 3 seconds. Which means she has covered 15.6 meters. And then we can just use the Pythagorean Theorem to determine z. So actually the Pythagorean Theorem we're going to use here is this one right here. This one. To determine z. So z squared equals 12.6 squared plus 27.4 minus 15.6 squared. And that means that z, if we evaluate this, we're going to get 17.26 meters. So that's the distance between Steve and Mary after 3 seconds. Okay, so at this point, now that we know x, y, and z, and we know the rates at which the two are running, we can plug it into this expression and we can solve for dz dt. So we're going to get, like this, we're going to get 12.6 times 4.2 plus 27.4 minus y, my y was 15.6, times negative dy dt was negative 5.2. Well, it was 5.2, but there's a negative sign in front of it, so it will become negative 5.2. Equals to z, the distance between them was 17.26 times dz dt. And now if we evaluate the left-hand side here, and then we're going to end up dividing by 17.26, so we're going to get a dz dt that equals to negative 8.44 over 17.26, which equals to negative 0. And they wanted to have the answer to 2 decimal places, so it's going to be 0.49. And it's meters per second. Oops. So this means that the distance is decreasing after 3 seconds, is decreasing at the rate of 0.49 meters per second.